Press to start. Okay, and a quick look around the circuit diagram. There's the battery. It then feeds the 12 volts via the 25mm cable down to the junction box or fuse box, down this buzz bar to fuse number 4, which is a glow plug fuse, back round to relay number 4, which is the glow plug relay. When the relay closes, it goes out on there. There's a 6mm cable coming out, and you come to that junction there. We'll come back to there in a minute. Look at the switching side. This side of the relay is connected via the brown wire through fuse 11 back to engine control module relay, which is the ignition relay. So when you turn the ignition on, that side of the relay goes to 12 volts. The other side of the relay comes up here and to the engine control module. So the engine control module switches that to ground to turn the glow plugs on, and then coming back to this junction, when this goes to 12 volts because the relay is turned on, it sends a signal back here. There it is, to fuse number 1, through fuse number 1, which we'll come back to at a later stage. It goes down there and that blue wire back to the engine control module. So that tells the engine control module that the battery, the fuse and the relay are all working, but it doesn't tell it if there's a fault on one of the glow plugs or all of the glow plugs. All it says is that it's sending 12 volts to the glow plugs. So come back to there, and goes off to K on sheet number 4. So there's sheet 4, and there's K. So it comes across there on the 6mm cable again, splits into 4 separate 2.5mm cables, which go to your 4 individual glow plugs. And they're grounded on your engine through the engine ground. A modification that many people put on their Freelanders is an extra earth cable onto the engine ground from the battery negative. All you need is a 35mm cable, roughly 1 metre long. Freelander glow plugs are 1 ohm resistance each, so 4 of them in parallel will give you 1/4 ohm resistance between ground and the supply to the glow plugs. If I measure the resistance across this, it should read 1 ohm. That's not bad, but if I cross these together, it should read 0, and it doesn't. So measuring the resistance of a glow plug is not a great way to test them, unless you've got a special meter that can measure really low impedances. A better way is to measure the current. So the current should be around about 10 to 12 amps per glow plug. So a set of 4 together will be between 40 and 48 amps. This is a DC clamp meter on a jump lead going straight across the 12-volt battery. It starts off at about 15 amps and as it warms up drops down to about 7 amps. I've taken the glow plug relay out. That normally lives just there, and I've also taken the fuse out. That is fuse number 1. That sends a signal back to the ECU when the glow plugs are on. So 12 volts from the battery goes down the 25mm cable into the fuse box just there and connects to that buzz bar. That then goes to fuse number 4, which is under there somewhere, which then comes up to the relay, which has been removed, that contact to the relay, and when the relay switches on it switches 12 volts onto that contact and sends it to the glow plugs. So we'll put this cable into there, so now I can feed it directly into the glow plugs. Put my meter on 200 amps, zero it, there we go, and feed 12 volts directly through to the glow plugs. Starting at 46, dropping down as they warm up. As it warms up, that's with 4 good heater plugs. Quite easy to make if you want to make yourself one. Basically a little moving coil meter in parallel with a piece of 4-volt cable. Okay, I'm in a little ammeter. If you want to have a go at making your own meter, it's quite simply a moving coil meter in parallel with a length of 4mm cable. So now I can check my glow plugs before winter sets in.